Good morning. Let's start doing some chemistry. So I'm going to go ahead and share my screen. We're going to go over phase change diagrams today. So this is going to be on page 10 in your packet. So phase change diagrams are going to look something like this. We're only going to be looking at the phase change diagrams for water. All right, so we don't have to worry about anything else. Now you'll notice that on the y-axis over here we have increasing temperature. And then on the x-axis down here, we have increasing energy. Now, these diagonals on the phase change diagram represent your states of matter. So which state of matter has low energy at low temperatures? Well, that's going to be your solid. And then the next one, the next diagonal is going to be your liquid. And which state of matter has high energy at high temperatures? Well, that's going to be your gas. Now, these horizontal lines here, those represent your phase changes. So when you go from solid to a liquid, you're going to have your melting. Going from liquid to solid is your freezing. Looking up here between the liquid and the gas, going from liquid to gas, we have evaporation. Going from gas to liquid is called condensation. Now we have these areas here between where the phase change is occurring, and there's an energy associated with that. And so here it's called the heat of fusion. And on this side, it's called the heat of vaporization. The heat of fusion is talking about how much energy is required to change 1 gram of a substance into a state between your liquid and your solid. The heat of vaporization is how much energy is needed to evaporate or vaporize 1 gram of your substance. For water, those values are down here at the bottom. The heat of fusion for water, which is between your liquid and your solid, that's 334 joules per gram. The heat of vaporization for your water is 2,260 joules per gram. Okay, make sure you get those down. So we're going to look at some different problems with our phase change diagram. So first one here on your paper, it says how much heat in joules is needed to heat 150 grams of liquid water from 0 degrees to 20 degrees. When you're doing these kinds of questions, I really do recommend looking at your phase change diagram and then just making a little arrow next to wherever it's talking about. So in this question, it's talking about right here in the liquid state of matter. So when we do this, it's going to be just the same way that we were doing problems last week. So these kind of problems are just happening where there's a temperature change. Okay, so we see a temperature change. There's no phase change here because it's a liquid from, hang on, my bar is covering this, from 0 to 20 degrees. So we're just in the same state of matter. We're not changing states, we're just changing the temperature. So if it's just involving a temperature change, we use Q equals MC delta T because we're dealing with the temperature change. So we're looking for Q. Our mass is going to be 150 grams of water. Our specific heat, 4.184 joules per grams. And then our temperature change, we're going from 0 to 20 degrees. So our temperature change is going to be 20 degrees. 20.0 technically for sig figs. So when we calculate that here, we have 150 times 4.184 times 20. So that gives us Q is equal to 12,552, but we want to round to sig figs. Our temperature change only gives us 3 sig figs, so rounding this to 3 sig figs would give us 12,500. So if there's a temperature change and no phase change, we just use Q equals MC delta T. Now this one, let's again look at your diagram, make a note of what it's talking about. So it says how much heat in joules is needed to melt 150 grams of ice at 0 degrees. So we're right here, melting ice at 0 degrees. Now on this question, we've got a phase change. How do we know I have phase change? Well, it's talking about melting. All right, is there a temperature change? No. So if there's only one temperature given, we cannot use Q equals MC delta T. We have to use Q equals M times H. We have two different H's. We have HF and we have HV. This one, because it's happening down here in the freezing melting phase change, we use a HF to represent the heat of fusion. So then we just plug everything in to solve for our Q. So Q equals 150.0 grams of ice. We have no specific heat, no temperature change this time, and our heat of fusion for water is 334 joules per gram. So then when we calculate it, we have 150 times 334. So that should be 50,100, and we have enough sig figs. So technically we should put this in scientific notation, but let's not worry about that. 50,100. No Q equals MC delta T because there was no temperature change. All right, this one here, I just wanted to put this one in the packet, in the PowerPoint. It's not in your packet, but just to kind of show you how this goes. So this one is talking about how many joules are needed to turn 15.0 grams of water into vapor at 100 degrees. So again, make an arrow to indicate where we're talking about. So here in this problem, we have a phase change because we're trying to turn water into gas. There's no temp change. So we have no Q equals MC delta T. So that means we're going to use Q equals M times H something. Now, because we're up here with condensation and evaporation, we're going to be using HV, the heat of vaporization. So to find our Q, we plug in our mass, 15 grams, and we plug in our heat of vaporization, which is 2260 joules per gram. So then to solve, we do 15 times 2260, and we should get 33,900, which is the right amount of sig figs as well. All right, so no Q equals MC delta T because there's no temperature change. So these problems, though, can get a little bit tricky. So when you look at this, this question says, how many joules are needed to convert 5 grams of ice at negative 15 degrees to steam at 130 degrees? So we're going from here to here. So as you can see, we have temperature change and we have phase change. Okay, so we have temp change and phase change. Now, if you draw arrows on your phase change diagram, it helps you to see how many steps you have. So we're going from here, this is 1, 2, 3, 4, 5. We're gonna have 5 steps to complete this problem. So our first step is at this diagonal, so that's Q equals MC delta T. So this is gonna be our temperature change when it's ice. So then that's going to be our mass, which is 5 grams. Now this is ice here, so we have to use the specific heat of ice, which is 2.09. That's a 9 joules per grams degrees Celsius. And then our temperature change. Well, when is ice going to change into liquid? It's going to change into liquid at 0 degrees. So how many degrees is this sample going to be ice? It's going to be ice for 15 degrees. So we calculate this, 5 times 2.09 times 15. Let's not round to sig figs until the very end. So 156.75. Now our second step, right here, that's where it's melting. So here it's phase change, no temperature change. When you're at the horizontal, you use Q equals M times H, whichever one it is. This is HF because it's down at the melting. So we have our mass, 5 grams, times our heat of fusion, which is 334 joules per grams degrees Celsius. So then we have 5 times 334, and that's 1670. Our third step is right here where it's water. So that's where we use Q equals MC delta T again. When it's at the diagonal, we use Q equals MC delta T. So we have 5 grams still. Our specific heat of water this time, it's liquid, so it's 4.184 joules per grams degree Celsius. And how long, what temperature range is it going to be water? Well, this is going to be 0 degrees, this is going to be 100 degrees. So it's going to be water for 100 degrees. So we've got 5 times 4.184 times 100. So this is 2092. Our fourth step is right here where it's horizontal. So that's going to be Q equals M times H. V this time because it's vaporizing, it's turning into a gas. So we have 5.0 grams times our heat of vaporization, which is 2260 joules per grams. And that's going to be 5 times 2260, 11,300. And then our last step is way up here where it's a gas. So it's at the diagonal, so we use Q equals MC delta T. So we have our mass, 5 grams. Now it's steam, so we have to use the specific heat of steam, which is 2.01 joules per grams degree Celsius. All these specific heats are on that reference page in your packet, by the way. Now, what temperature range is it going to be gas? Well, it turned to gas at 100 degrees, and we're heating it to 130, so we've got 30 degrees, excuse me, down here. So we have 5 times 2.01 times 30. That's 301.5. Now to get our total heat, we have to add all of these numbers together. So we have 156.75 plus 1670 plus 2092 plus 11,300 plus 301.5. So that gives us a grand total of 15,520.25. But let's see, we should only have 2 sig figs, so we're going to change this to 15,000 joules. All right, so where students typically make mistakes on this is they make mistakes in figuring out the temperature range. So on those Q equals MC delta T's, it really needs to be for whatever temperature range is that state of matter. So when you're looking at this, how much temperature, what's the range that's going to be ice? What's the range it's going to be water? What's the range it's going to be gas? Make sure those temperature changes reflect the temperatures at which it's that state of matter. Okay, that's the biggest area where people make mistakes on this. Let me just pop all of this up. Okay, so this one is going to go on to page 11. The next page, this is your first problem that you'll have to do on your own, but we're just going to walk this through. So this one says 8.75 grams of ice at negative 5.7 degrees Celsius would need how many joules of energy to be a liquid at 45.9 degrees? Like I said, make a little arrow of where you're starting from and where you're going. There's only one arrow here, so let me draw in another arrow. We're starting right here, okay? And we're going to this green arrow here. So that's going to be 1, 2, 3 steps. So there's going to be a temperature change. There's going to be a phase change. So our first step is at the diagonal when it's ice. So we have to use Q equals MC delta T. You use this anytime it's at a diagonal. So our mass is 8.75 grams. The specific heat of ice is 2.09 joules per grams degrees Celsius. And then what's the temperature change when it's ice? So here it's going to change into liquid at 0 degrees, so it's ice for 5.7 degrees Celsius. So we multiply that, 8.75 times 2.09 times 5.7. So it's going to be 104 0.23875. Remember, we're not going to do sig figs to the very end. Our second step is right here at the horizontal. So we do not use Q equals MC delta T here. We use Q equals M times H. Which one's it going to be this time? HF. So we've got 8.75 grams times HF, which is 334 joules per grams. Multiply that out. So this is 2,922.5. And then our third step is where this green arrow is. That's when it's our liquid. It's at the diagonal, so we have to use Q equals MC delta T. So our mass is 8.75 grams. Our specific heat of water now is 4.184 joules per grams degree Celsius. And what's the temperature at which this is a liquid? So we're stopping at 45.9 degrees. We started being a liquid at 0 degrees. So this is going to be 45.9 degrees Celsius. So 8.75 times 4.184 times 45.9 is going to be 1680.399. So remember, then we had to add all of these up. So we had to add 104 point blah, 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 plus that 2,900 number, plus that 1680 number. So this should give us 4707.13775. But looking at the problem up here, we should only have 2 sig figs, so 4,700. Or I would give you 3 sig figs because the temperature changed it. Anyways, 4,700. Okay? You want to make sure you're doing the correct amount of steps when you do these problems. You want to make sure that you have the correct temperature ranges. Not every problem is going to be a 5-step problem. Not every problem is going to be a 3-step problem. So make sure you figure out how many steps you need to solve for your problems, and let us know if you guys have any questions. So finish up page 11, those 8 problems. I've already done one for you, so you've got 7 more to go.